The number of rabbits increases according to this model, where T is the time in years and NT is the population at time T. A is the initial size of the population and B is the relative growth rate. Rabbits are introduced to a small island 8 years ago. I'm going to highlight that. Only because I know that if we're looking 8 years ago, there's going to be some tricks. The current rabbit population on the island is estimated to be 4,200 with a relative growth rate of 55% per year. Now, we've seen that before. Relative growth rate is B, 55% per year. So that means already that we know that our model NT is equal to A, E, and B is going to be 0.55 or 55% with respect to times T. So what was the initial size of the rabbit population? It's introduced 8 years ago. Then that means that that's when T equals 0. So T equals 0 8 years ago. Okay, so what was the initial size of the rabbit population? Let's start chugging. So the current rabbit population, NT, is equal to 4,200 when T is equal to 8. The current population is 8 years since they were introduced. So 4,200 is equal to A, E to the power of 0.55 times 8. So then that means that A is equal to 4,200 divided by E to the power of 0.558. A equals 4,200 divided by E to the power of 0.55 times 8. Execute. Okay, so then that gives me 51.56, or let's say initially there are 51 rabbits. Now, I don't think that you can get marked down for rounding to 51 or 52, but, I could be wrong. Okay, so there are 51 rabbits. Okay, so estimate the population 12 years from now. If it is 8 years ago they were introduced, 12 years from now is going to be T equals 20. The past 8 years plus the 12 current years. Okay, so let's write our new model. NT is equal to 51. Now, you might incur some rounding errors. I don't know if they can mark you down for that. Probably not. 51 multiplied by e to the power of 0.55. And we are going to input when t equals, and then we're going to let t equal 20. Therefore, n of 20 is equal to, punch that in our little calculator, 51 e to the power of 0.55 times 20. Execute. Whoa, that's a lot of rabbits. 3,000. What is that number? 3,053,581 rabbits. 0.227. Whoa, a lot of rabbits. Okay. Determine when the population is increasing at a rate of 250,000 rabbits per year. So we want the population, so we want the derivative with respect to time of our NT, not PT, is equal to 2,000 250,000 rabbits. Okay, that means that this is probably something we can do using solve n. You could do the derivative, work it out from there, but we already know that nt is equal to 51 e to the power of 0.55, and we're solving with t, therefore solve. And in the calculator, we're going to put 250,123 is equal to the derivative, x, we'll make it an x, the calculator likes x, of 51e 0.55 x. Now you've got to put the comma x in. A lot of you leave that out. Your calculator will at some point screw you because you do that. Options, calc. I'm using solve because sometimes with exponential functions, solve n gives me like an infinite list. Don't always love that. 1, 2, 3, shift equals the derivative of 51 e to the power of 0.55 x, and comma, we don't know what x is. We want you to tell us what x is. So now, comma, solve for x, close bracket. Sometimes when you do this, it just takes a bit of brain power. I remember last year there is a question somewhere where it took maybe like 5 minutes to get the answer, so just be aware of that. Okay, so our answer then is, it is when t is equal to 16.536. So determine when the population is increasing at a rate of 2,500. That is when t equals this. So 16.536 years. Poppy, Gabby, stop it. Or you could say, because we've already had 8 years lapse, it'll be 8.536 years from now.